I'm so thrilled to be here with you, Jensen. It's really an honor to get to learn from you. I wanted to take it back to the moment when you gained conviction around the deep learning. Do you remember when that was?
Very, very well. I learned about deep learning about the same time everybody else did, and maybe slightly before that. And it was because several pockets of researchers were simultaneously trying to submit for ImageNet, that big contest in 2012, and wanted two things: access to the latest GPU, which was the GeForce GTX 580. It just come out, and also learn how to program it, and for deep neural nets. And so we were fortunate to have learned about them a little earlier, but it was called neural network. And as you know, during that time, artificial intelligence wasn't very popular, and neural networks were suspicious and a questionable area of research. But nonetheless, we were helpful and we were the best we could. But the thing that really stood out for me was that how effective it was.
Yeah.
And of course, the next question when you see effective technology that's surprising is how would this scale? What other problems can it solve?
Yeah.
Because of the nature of the deep neural network and each one of the layers isolated from the other, and the backpropagation approach so effective, you could imagine scaling this tremendously.
Yeah.
And it turned out we were right. But the observation that we made was that deep learning was both an algorithm for solving problems that were difficult to specify. It was also a new method of developing software. Imagine you had a universal function approximator of any dimensionality.
Yeah.
And irrespective of the dimensionality and the size of the problem, so long as you have a large enough model, you could backprop it and learn it. And extrapolating that insight, I think, was really important for us. And we came to be very convinced of its potential. And because we realized that it was going to be a new way of developing software.
Yeah.
And since then, our Carpathy has called it Software 2.0. But we observed that it was a new way of doing software in the beginning, and realized that maybe we need to change computing altogether.
Yeah.
And since then, you could look back and realize that maybe for the very first time in 60 years, since the System 360 from IBM, that accelerated computing using GPUs and deep learning really reinvented computers.
Yeah.
That we might have discovered quantum computing before quantum computing, if you will.
Exactly.
And I think that was a really important moment. We were fortunate to have connected all the dots.
Exactly. Yeah, I remember reading the paper from Ilya and the folks and how they had started deploying it, and it was incredibly impressive because no one had really put GPUs to that use previously. But ever since, sort of the model architectures have started evolving a bit. Where do you think they're heading next? Back then it was the CNNs. We're now seeing increasing bets on multimodality. What makes you excited about that, and where do you think the model architectures are heading?
Well, let's see. Transformers and the work that researchers have done to reformulate just about every problem, every type of data into something that a transformer can learn. You could create a vision transformer. You could create a audio transformer. You could create, of course, a text transformer. You could create a transformer just about out of anything, it seems. And multimodality is really important for very, very clear reasons. They're higher performance. So, for example, if we're to say, you're trying to train a neural network for vision, and you've seen nothing but horses, and you've never seen zebras, But if you added another modality to it, like words, and you understood that a zebra is a horse with black and white stripes, somehow the combination of images of a horse and the words and the understanding of black and white stripes
Exactly.
Combined allows you to imagine what a zebra is without ever having seen one. And so you've extended your performance. You could use multimodality to enhance the robustness of perception. So we do that for cameras and radars and LiDARs. We combine multiple sensor modalities so that we can extend the capabilities of your perception to encompass the superset of all of them.
Yeah.
You could also I guess enhance the capabilities with ambiguous things. Like, for example, if I were to say, "What is that?" The combination of my words and my gesture helps you understand what I meant. Hard to do that with pronouns.
Exactly.
With words, and so multimodality is really important. And now we have the transformer model, and we've expressed transformers in a way to understand multimodality. And so I think that the next generation of AI models are going to be more performant, more safe, more robust, and do more things. I think it's going to be a big deal.
And I think what's really fascinating is just how much we've already been able to derive from language. That we've basically derived this world model from language that we can apply to very wide contexts. But you also speak about teaching these models physics. Do you think that's needed, or could we derive it as these models become multimodal? Will they be able to learn that from the training data as they get trained on video, for example?
Yeah, I think you can. Let's see. The just about you can imagine just about everything has been described in words.
Yeah.
Physics has been described in words. Newton's law has been described in words. So you could imagine that we can learn through the world's corpus of words just about all of the physical effects. If you've never seen the color red, it's really hard to imagine what red means.
Yeah.
But I wouldn't be surprised if there's enough poetry that describes the beauty of a red apple and how it compares to something else that's red, and the heart-shaped red emoji or something like that. And through all of those words, you've connected. Oh, this must be red. Through compare and contrast, and you must be able to learn that without having ever seen it. But I don't think you'll ever understand the sensation of something and the subtleties and the nuances of it without having the ability to combine all of these different things. I think it's possible to teach people the effects of physics, but if you wanted to predict the laws of physics, things that have physical phenomenon, you wanted to ground the AI in physics. Yeah. And it's no different than grounding large language models today using reinforcement learning human feedback.
Yeah.
In the future, you use reinforcement learning physical feedback.
Yeah.
And that physical feedback would instead of a human doing it, that physical feedback for a robot would be expressed in some kind of a physics simulation. And we created this system called Omniverse that obeys the laws of physics, so that we can give Omniverse essentially the digital twin of the robotic, the embodied robot, if you will. Yeah. And that embodied language model would then get reinforcement learning physical feedback, simulated physics feedback, digital twin feedback through Omniverse. And so I do think that you want to be grounded in physical truths for some types of robots. You want to be grounded in ethical truths, and that's alignment. One way of helping us create safer chatbots. So I think the two ideas are somewhat parallel, and it's somewhat sensible, and I think it's going to be helpful.
Yeah, that's probably how we all ended up in this simulation. It was you started doing these experiments.
Exactly.
Where do you think the cap goes? Do you think we can keep running with the existing model architectures, evolve them slightly, scale compute, or will we need radical breakthroughs and see diminishing returns quite soon?
I think, first of all, I don't know the science behind it, but the intuition would suggest that there are many aspects of our intelligence where we apply rules, and rules that are either learned, rules that are expressed.
Yeah.
There are many principles and rules in our company, in particular society, in particular cultures, that are expressed simply through words. You didn't learn it into existence.
Yeah.
Thou shalt not kill was not one of those things that we learned by trying everything until we discovered that thou shalt not kill. We just, we just learned it.
Yeah.
We were given that rule, and so there are many rules that can be expressed without having it be learned. And I think there's that form of symbolic reasoning that could augment these exhaustively learned models. And so I don't know what the science is behind it, and whether it suggests one way or the other way, but it seems intuitive that we augment our intelligence through things that are learned through reinforcement learning, and things that are learned through experience, things that are learned through just because that's the way it is.
Yeah. One thing we're so excited about at Sana is really this possibility to augment the human intellect now as well. If we could provide researchers with the tools to run thousands of parallel experiments and get augmented by this rather than replace it, how do you view the role of humans in this over time? Once we reach a point where this is orders of magnitude more intelligent than humans, what role do I have to play anymore?
I don't know. I don't know, but I'm surrounded by people who are orders of magnitude more intelligent than I am in certain skills.
Yeah.
And I have no trouble coexisting among them. and so I am already living in an environment where I'm surrounded by super intelligence.
Yeah.
Relative to myself, I feel like they're able to do things that I can't imagine doing.
Yeah.
And somehow I exist, quite harmoniously within it. I do think that we are going to elevate basic intelligence. We've elevated many things that over time has commoditized a very, very important human resource. We democratized the hunting of food by farming. We didn't have to, run after or be chased after by food.
Yeah.
We democratized, of course, the production of power, and so, people who are smaller and weaker can live in a world where things are rather heavy, and so you don't have to be just gigantic and muscular to exist in that environment, and we democratized the access of energy, and as a result, society elevated in its capabilities, and I think that we're now democratizing intelligence, the production of intelligence, and but I think value will still go to people who have deep domain expertise, some incredible passion, which is now elevated, as you mentioned, through the ability to try all of these future scenarios so that we can amplify our own passion and our own expertise. The other dimension of it, which I'm hopeful for, is that for the last 40 years of my career, the vast majority of population has not learned how to use this instrument that we call the computer.
Yeah.
Only a handful, and I think you started learning how to program the computer when you were early teens.
Yeah.
And for the vast majority of the world, They don't know BASIC. They don't know Python. They don't know Pascal or Fortran or C or C++ or Java. Or, they don't know how to program these computers. And even though it's very sensible to a small population of the world, call it 1 million or so, the billions of people have no clue how to do this until now. And now with ChatGPT, as you know, the programming language of choice is human. And you could program it in Swedish, and I can program it in English, and you can program it to write a program to program another computer. And so we democratized programming for the very first time in history. And I can't help but believe that that's going to empower billions of people who currently see this instrument of value creation and this instrument of productivity. This incredible light speed traveling machine that we sit on called the computer. For the first time, everybody can have access to that. And so I'm hoping that it's going to bridge the digital divide. I think you could make a case for that. And you're seeing it happening right now in real time with kids on the internet prompting these machines, writing amazing programs, generating beautiful images, and they're just kids. They didn't know how to write a program, but they could do this. So
I think that's really fascinating as well with how you're accelerating compute at Nvidia, because you're using AI yourselves to develop more advanced compute. Could you tell me what that cycle looks like?
Well, our current generation of chips are so large and so complex, all the employees in our company can't possibly design it. And so we use AIs to help us explore the design space. And as you said, experiment with hundreds of thousands of permutations of the design and find us the one that has the best trade-offs.
Exactly.
And the best trade-offs are trade-offs that we determine. There is no perfect optimization. There's just an optimization that's best on some trade-off. And sometimes we might want to trade it off on speed at all expense. And the reason for that is it's the critical path. And you want to make that critical path absolutely as fast as possible. Maybe it's because it's something that you have to instantiate thousands of times, and now energy efficiency is really important. So you optimize for energy efficiency. And so we make those kind of judgments, and then we set the AI free to go and discover all these corner conditions and all these different permutations for us, and it comes back with a design that no human can do. And that's really quite amazing that we're looking at these designs that we've put into the latest generation Hopper that no human has ever designed before. And it's that incredible. And so, or it's because we have to connect thousands of modules on a chip, and the combinatorial explosion of thousands of combinations is more than all the atoms in the universe. And so only an AI can figure out what is the best optimization for that.
One other question I was really intrigued by your perspective on is, how should we think about defensibility? Last time we spoke a bit about the value of domain expertise and really integrating yourself deeply into workflows. But for companies executing on the application layer, how should they think about defensibility as these models become increasingly commoditized? They're able to learn from smaller and smaller amounts of data. A lot of the historical moats don't seem to apply anymore. How should we think about building a defensible business?
Mm-hmm. Well, I don't know that there's any evidence that understanding a domain of problems or understanding a segment of customers has ever lost its value. Our technology, the world's computing technology, and the number of well-educated people obviously growing. The new college grads that are coming out of universities these days are really quite amazing. Just about every single one of them were smarter than we were when we first graduated. And the type of problems they can tackle just from graduating from school were the type of things that entire companies used to do. And yet there's every every evidence would suggest that understanding deeply your customers' challenges and is really quite valuable. And so I think that's not going to go away. We're going to have incredible basic AI capabilities, and it could do amazing things. It could solve all the hardest math problems, and it'll pass bar exams, and yet we know very well that somebody who's passed a bar exam, when brought into a domain of a particular issue, still has to learn about the fundamentals of that industry, and what is the problem that needs to be solved, what are the complex relationships between people. Oftentimes customers are people, and they have complicated challenges that they're trying to solve themselves. And so understanding people, understanding the context, and oftentimes those things are poorly expressed. And so those are social science problems.
And what are you most excited about on the application layer?
Well, for us, there are three. I would say that if I can categorize it into three things. What are the things that AI can do that can enhance, revolutionize the work that we do to build our products? So that's one. And we were just talking about one. The way that we design chips has completely changed. The second, the way that we design software has changed. The second, of course, is what are the things that AI can now enable us to do so that our products are different?
Yeah.
Revolutionizing not just the way we design our products, but revolutionizing the products that we build. So, for example, there are many gamers in the world, and the way that we used to build a graphics card, we would design programmable shaders, and of course there was compilers and things like that. But that's it. We ship it, and we ship a great processor with great compilers, and we integrate them with games and such. But now you can't even ship a GeForce by itself because there's a supercomputer in the back learning how to make predictions of the missing pixels, because we have to denoise and we have to infer pixels. We infer about out of every one pixel that we render, we now infer somewhere between 8 to 16 pixels. I mean, it's like getting a jigsaw puzzle where you're giving one piece and you're supposed to guess the other 16.
Yeah.
And so we taught an AI. We have a supercomputer in the background just learning how to do that and improving the algorithm. And then we download the algorithms whenever we improve it.
Yeah.
And so now we use AI to revolutionize not just the way we design that GPU, but the way that the GPU even produces the images. And so it helps us create much more energy efficient processors that exceeds any capabilities that Moore's law would have predicted. And then the other thing the third category I would say is where your world is, which is to turn the whole company into an AI.
Yeah.
And so that all of our employees are augmented by this, system that is running all the time.
Yeah.
And so that we're not searching for information that we'll never find. So that maybe we can connect dots and predict opportunities in a marketplace, or maybe the supply chain has changed, or maybe the market demand has changed, and it's impossible for us to see all the signals. But it's not impossible for an AI to see all the signals.
Yeah.
And so over time, from the way that the employees work with each other, the way we learn about the information that we need to use, to the way that we forecast demand and work with our supply chain, all of that is going to be revolutionized by AI.
And what do you think is your most contrarian view on AI right now?
I don't know that I have anything that's particularly contrarian, because if you look at the world today, most of the conversations about AI are either beyond enthusiasm for its promise and beyond concern of its perils. So somewhere between the extreme conditions of promise and peril, which is being discussed in real time all the time, probably is the truth. And there's no question that technology of this capability, and throughout history, technology of any capability has brought enormous transformations and discontinuities in society and economy. And so there's a fair amount of peril that we have to consider.
Yeah.
The type of, who would have thought that there would be a whole bunch of people who are doing web designers?
Yeah.
This is a profession that didn't exist, or programmatic ads.
Yeah.
These are professions that didn't exist when I came out of school 40 years ago.
Yeah.
But they're entire industries today. And so somehow this enabling technology called the internet has recommender systems. The early versions of AI has made it possible for us to create this new industry. I think that we're going to have to reskill, retrain, and so that jobs that are dislocated could be transformed. But I'm certain that there will be brand new industries that are created that we never thought of. Like, for example, right now we are seeing this coming alive in real time is prompt engineering.
Yeah, exactly.
Right?
Yeah.
Prompt engineering is like, it's going to be a real thing. It's going to be a giant industry. It could be the most important programming industry.
Exactly.
And so how many people are going to be prompt engineers? It's incredible. You're seeing AIs that are helping write prompts, right? To prompt other AIs.
Very meta.
Yeah, it's very meta indeed. Yeah. And so I think we're going to see all of that. And so I think there are a lot of good things that are being discussed. I love the conversation around safety.
Yeah.
We have to dedicate as much in technology investment in the capabilities of AI as well as the safety of AI.
Yeah.
We happen to work in the field of self-driving cars, and we probably have just as much resources dedicated to making the AI safe and the car safe as we do making it drive. And so I think large language models will have to do the same, and the technologies associated with building AIs for guardrails, so that you keep it in the operating domain, to technologies related to alignment, reinforcement learning, human feedback, which is like reinforcement learning with physical feedback that we were talking about earlier, to technologies of vector databases that reduces the ability or reduces hallucination, so you augment it with facts.
Yeah.
All of those capabilities, I think we're going to see just an explosion of new ideas to transform that core large language model, surround it with other AI technology and methodologies and best practices. All of that is going to turn that large language model into usable chatbots.
Exactly. Yeah. One thing I admire so deeply about you is how technically current you stay. I think you must spend a lot of time reading or whatever, but you're always so incredibly thoughtful and well-read in every single detail of what's going on in the industry. How to stay so on top of things while running one of the world's largest companies.
Wow. Let's see. What's the answer to that? Well, first, I'm surrounded by amazing people. When I went to visit you, you were surrounded by amazing people.
Yeah.
And they're generous to teach me, and so you have to make the effort to learn.
Yeah.
People are love teaching people who are great students.
Yeah.
And so I dedicate myself a lot to being a good student.
Yeah.
And of course, we're in a whole lot of domains, from self-driving cars to climate research to digital biology.
Yeah.
And so the vastness, the breadth of impact that we can have in the world is great. But we also have to learn to be able to, and so you're in a very tech-driven industry, solving and creating solutions for companies.
Yeah.
I'm in a very tech-driven industry. And so for both of us, it's essential we understand the underpinnings of the technology, so you have an intuition for how the industry is going to change.
Yeah.
You have an intuition for how which one of the technologies is a little bit of a left turn, and which one is fundamental.
Yeah.
To realize that maybe the early works that we did with generative adversarial models, to variational autoencoders, to diffusion models, that they were somewhat cousins of each other.
Yeah.
And that realizing the impact of one could lead to breakthrough in another, which opens up the horizon for now diffusion models that are utterly incredible. Yeah. And so I think having an intuition for technology allows you to better extrapolate.
Yeah.
And our ability to extrapolate and see down the road is really vital because gosh, technology is changing fast, but it still takes us several years to build a great solution. And so how do you on the one hand dedicate yourself to build something that's going to take years to do, building it on top of technology that's utterly changing, by a factor of 1,000 every few years. How do you do that unless you have an intuition for it? And so I think that the fact that you're so deeply gifted in technology, and so you understand and you have great interest and curiosity in technology, is essential to running a technology-driven company. And so I think I love that part of my job, and I'm surrounded by people who are generous to teach me, and I've got to just dedicate myself to be a good student.
So one area I'm very intrigued by is how you run the company. I've understood you don't have one-on-ones. Can you talk me through some of the sort of classic management playbook that you've challenged and evolved?
Mm-hmm. Well, first, with respect to building a company, the first thing that you have to go, as with all problems, and Joel, you do this very naturally. You start from first principles. What is this machine that we're trying to create, and what is its output? What is its input? What is its output? What are the conditions that it's in? What is the industry like? Is it a fast-moving industry? Is it a bureaucratic industry? Is it highly regulated industry? What kind of industry is it? And what are you trying to build? And so I think you think about it from that perspective. There are several things that I wanted to do with the company. I wanted to create something, a company that naturally attracts amazing people. And the reason for that is because we're solving problems. Our company's mission is to solve computing problems that are barely possible. And if a problem could be solved by normal computers, we don't do it. And so we have to go find problems that are impossible for normal computers to solve, or barely possible. And so you want to attract amazing people who want to invent this new form of computing and apply it to solving some really difficult problems. And so I wanted amazing people. Second, I wanted a company that was smaller, not larger. You want a company that's as small as possible, not as large as possible. It needs to be as large as necessary to do the job well, but to be as small as possible. And so naturally you want to empower people. Well, if you want an organization that obeys command and control, then you make it a pyramid, just like the old military, all the way back to the Roman Empire. And but if you want to empower people, then you want to make it as flat as possible, so that information travels quickly. And so in order to make something as flat as possible, the first layer has to be well considered. Well, the first layer happens to be the most senior people, and you would think that they need the least amount of management. Nobody's coming to me. None of my management team is coming to me for, career advice. They made it, and they're doing great. And so I have a whole lot of people reporting to me because I don't need to do one-on-ones. I don't have to do career coaching. I don't have to. They're all fabulously happy, and they know what they're doing. They're experts in their field, and so those one-on-ones are really not necessary. And if there's a strategic direction, why do you tell one person? You tell everybody. And so after we're swimming in the soup of strategizing and how to formulate the path to the future, when the time comes, I just, I send it out to everybody at the same time, or I'll tell everybody at the same time. And people will give me feedback and we'll refine it. And because the company is so flat, and you've empowered the organization so much with knowledge of the company and their access to information, the company is also agile. And so it turns out that by having a lot of direct reports, not having one-on-ones, made the company flat. Information travels quickly, employees empowered, which made it possible for me not to do one-on-ones. That algorithm was well conceived.
Yeah.
And the architecture is well implemented. We also don't have business units. We don't have divisions.
Yeah.
Everybody works as one.
Yeah.
And the company is shaped in a way that allows us to build accelerated computing best. If you asked me to go do fried chicken, we'd have a hard time doing fried chicken. Swedish meatballs, no chance. But accelerated computing, very well.
I think you have 40 direct reports, right?
Yeah, something like that.
Yeah.
Yeah. The challenge is getting everybody together.
Yeah.
When I want to get everybody together, but either somebody's out or somebody's on vacation or somebody's doing something.
Exactly.
Yeah. The odds of everybody sitting at the office is approximately 0%.
How did your leadership style change over time? You've been going on for decades now. How did that evolve as you learned?
Well, I don't really have a style. It's just me.
Yeah.
There are a lot of things that I want to do better.
Yeah.
And if something's happening at work and I don't like its direction, I'll just say it. Because I don't take anybody aside.
Yeah.
Do one-on-one coaching.
Yeah.
If something's not right, I'll just say it.
Yeah.
If I have a different opinion, I just say it. And so it could be a little too direct, but if people just realize that I'm not trying to do anything except be direct, and then I spend a lot of time reasoning through my decisions, which empowers employees because they learn how leaders think through problems.
Yeah.
And just by every meeting I'm in, I'm explaining, how do I think through this?
Yeah.
Let me reason through this.
Yeah.
Let me explain why I did that.
Yeah.
Why and how do we compare and contrast these ideas? That process of management, I think, is really empowering. And we also don't do just vice president meetings or just director and bullet meet. The meetings I have, there's new college grads in there. There are people from every different organization, and we're
That's
just
so
sitting. We're just all sitting in there.
Yeah.
They're kind of like your office.
Yeah. But
everybody's just kind of sitting in there.
Exactly. Like that's actually one thing that I found very intriguing because that's one of the playbooks, right? You have like a very clear leadership team and you have leadership team meetings and so on. And that's something I've always struggled with because you'll have a lot of the like best individual contributors. And of course, like they should be in that meeting. It shouldn't be just like vice presidents, not knowing the craft. So it's fascinating that you can.
That's exactly, you got it. You want the person who is most informed or best skilled or just had the most experience.
Yeah.
They actually made the mess.
Yeah.
Or they actually confronted the situation. You want ground truth.
Yeah.
You want ground truth and experts the best you can.
And you have some model for folks to communicate their top priorities. I've heard something about sending an email. What's that all about?
We have we don't do status reports.
Yeah.
And so I don't read any status reports. And the reason why I don't is because status reports are they're meta information by the time you get it, and so they're barely informative.
Yeah.
And so I've been distilled and refined, and bias has been inserted, and perspective has already been added, and you're not looking at ground truth anymore.
Yeah.
And so I tend to appreciate information that anybody presents.
Yeah.
And so you're allowed, if you send out email, and it's called top 5 things, and just whatever happens to be your top 5 things, whatever you observed or whatever you did or whatever you learned or things, they're just things.
Oh, really?
Yeah, top 5 things,
whatever
it is. Just went to a great restaurant. Who doesn't want to hear that? That's important information. And so just had a baby. That's important information.
Yeah.
So whatever these things are, top 5 things, if you send it out, I'll read it.
Yeah.
And so I read every single morning, probably 100 or so, and I do it every day.
And it's one giant thread that everyone in the company sends to, right?
No, just everybody has their own version of top 5 things, and they just send it out. If you send it, I'll read it.
What's your top 5 things?
Top 5 things are not meant to be from the center out. They're meant to be from the out. Yeah, there you go. That's right. Think of it as IoT.
Yeah.
If I take my top 5 things and I sent it out, then I've contaminated the system, in fact.
Yeah.
That's the reason why I don't do it. But I have my own top 5 things that I keep to myself.
And how do you balance that with planning? So sort of bottoms up ideas, having the best engineers on your team decide what to work on, combined with, sometimes you also have to execute on a plan. How do you balance those two things?
First of all, strategy is not words. Strategy is action.
Yeah.
And so if the company has a set of strategies, but the people's actions, their top 5 things are not that, then they're obviously not executing the strategy. And so the strategy, turns out, isn't what I say, is what they do.
Yeah.
And so it's really important that I understand what everybody's doing. And you do that by just getting a feel for everybody's top 5 things. And you don't have to read all of them. You don't have to read them all every week. You just kind of, is sporadic and, stochastically sampling the system, and you'll have a feeling for whether the company is going in the direction that you want it to go.
Yeah.
That we all agree we go. And so that's one. Second, planning. We don't do a periodic planning system. And the reason for that is because the world is a living, breathing thing.
Yeah.
And so we just plan continuously.
Yeah.
Yeah. There's no 5-year plan. There's no 1-year plan. There's no plan. There's just what we're doing.
That's really exciting to hear. I think one thing, as you're executing on first principles and you come to some ideas, it can also be hard to trust your intuition if you're doing something that's contrarian to what the playbook is. Mm-hmm. What do you think made you trust your intuition on some of these things?
Mm-hmm. Well, most everything that you dedicate the company to go after should be reasoned through first principles.
Yeah.
There's a foundation of what are the assumptions, the important assumptions that led to you believing that the computer has to change, or the chip architecture has to change, or the way that software is developed, or how a data center has transformed. A data center used to be a place where we store all of our files, and we would go retrieve it. But every company in the future will have more data centers, but one of the data centers will not be a center for data, but it's a factory.
Exactly.
It's a factory for producing intelligence.
Yeah.
And data comes in, it's refined through the computer, and what comes out is this invisible thing, which is the most valuable thing in the world, called intelligence.
Yeah.
And this building is going to be, driving this thing continuously, right? And so you and I, we're all going to have factories, and how would you reason through that? And you kind of back your way out, and before you know it, you formulate a view of the world based on first principle thinking, and then the next part is you go after it with enough dedication, with a conviction, so that you could realize it. Oftentimes, it's really hard. But if you're wrong, you change your mind, and that's the thing that's really great about modern leadership. If I'm wrong about something, I just say so. I'm just that was wrong. That was goofy. And then you say, hey, I changed my mind. And because you're adapting and literally replanning constantly. It's interesting that over time, people might not even notice that you've adapted 17 times in the last year. You've changed your mind maybe 35 times, And so if you don't do these giant 5-year plans, which I think 5-year plans are just horrible for technology, first of all. It's just ridiculous. And these continuous planning systems could maybe just lead to easier leadership.
One thing we were as obsessed about as the product we would build was the company we would build. And I think there's very few companies that are truly focused on empowering folks to do their life's work. And that has also been, a key passion of yours. And in how do you enable that? What are some things that you put into place to empower folks to do their life's work at Nvidia?
That is the mission of leaders, to create the environment for others, right? To empower others to do their life's work. And now, there's a couple of ways you do that. The most important way that realizing that mission is to not cause people to have to do commodity work. So, for example, we never talk about market share in our company.
Yeah.
And the reason for that is because why are you talking about, I have 23% market share and they have 27% market share?
Yeah.
Why are you fighting people for market share?
Yeah.
Because the whole concept of market share
Yeah.
says that there are a whole bunch of other people who are doing the same thing.
Yeah.
And if they're doing the same thing, why are we doing it? Why am I squandering the lives of these incredibly talented people to go do something that's already been done? And so unless we just enjoy the competition, which I tend not to, so we tend not to go fight people for market share, fight people for markets that are already commoditized. And so that's one way of thinking, to go do something that's never been done before. The other way is to demonstrate that is to walk away from businesses that has been commoditized.
Yeah.
And either through our own initiative or otherwise, we've walked away from many businesses in the past. And so that demonstrates very clearly to your employees that we're not going to go do commodity work. And so the combination of choosing the right work and walking away from the wrong work, that is the best way to create the conditions. And the rest of it is what you and I were already talking about, which is empowering people with information.
Exactly.
Whereas some companies are very siloed and information don't travel outside of organizations, I encourage our company to be rather transparent. And if you ask me a question about our company's secret, there wouldn't be that many secrets.
Yeah.
And so that empowers people.
Yeah.
And then the rest of it is how you conduct yourself during work.
Yeah.
If there's a sense of hierarchy in the company, then obviously that's not very empowering. But if anybody can come into a meeting and contribute, including a new college grad, that's very empowering. And so I think empowerment is a big deal.